Okay, so now, do you remember we talked about the chain rule? If we have the composition of two functions, if I have a function f and then after that g, of course this is wrong. G acts first and then f after that, yes. And then I get a new function h of x. The chain rule tells me how to differentiate this function, yes. The chain rule tells me that you for differentiating this, you take you differentiate the other function, but you calculate it at the point g of x, and then you'll need to remember that you have to multiply by the derivative of the inner function as well. Yes. So we solved some problems using exactly this formula, but I told you that it would be easier to if you think in this way. So if you give this g of x a new name, so let me call this one u, and then this becomes h prime of x is equal to f prime of u, but g prime of x is just simply u prime. So this u prime is the important thing that you need to remember when you are dealing with the chain rule. Yes? And I gave you some examples. And then I remember that I just give two examples that we use this method. So I want to practice a little bit more. This is a very important lesson. So now I want to give you a new example so that you can use this method to differentiate those functions. Okay. So I have already written them here. So let me write them for you. So example, I can start doing some of them myself, and then I will ask you to do the other ones yourself here. So I will give you a little bit of time. So let us do this one. So differentiate. So number one, f of x is equal to x squared plus 5x plus 2 to power 5. So we want to differentiate this function. So if you remember, the formulas that we have and you will get is this table. This is the only table that you will get in the exam. So the function, its derivative. If that's a constant, the derivative is 0. If I have x to power a constant, it becomes c x to power c minus 1. If you have e to power c x, yes, and then you get c e to power c x. And if you have a to power c x, you get c a to power cx ln of a. Okay, but this is the only thing that you will get, and of course more functions that we will study later. But you will not get any chain rule version of that. Okay, but if I want to write a chain rule version of that, this is very easy to generate it, so you don't need to use your memory that much. So assume that you have h here, and then you want to calculate h prime. So of course the constant is still 0, but assume that instead of x, you have u to power c. Okay, so u is a function of x. Okay, so you see, u is itself a function of x, not just x. If that is the case, so this will be given only to you. This is the only table that you will have in the exam. You need to understand the chain rule version of it yourself. And that's very, very easy. If you want to write a chain rule version of that, u to power c is comparable with that one. You use exactly the same rule, so it becomes c u to power c minus 1. But now that u is a function of x itself, you need to remember to multiply by an extra u prime. And actually, here you also multiplying by an extra x prime, but x prime is always 1. This is why you don't see it. Yes? And then, for example, if I want to write the chain rule version of that, how should I write it? E to power cu. What do I mean by u? U is not just x, any function of x. Then I use the same rule, c e to power cu, but I need to remember to multiply by u prime. So all of them contain a factor of u prime at the end. Yes? And then, for example, this one, a to power cu, it becomes c a to power cu ln of a, but you need to remember to multiply by a prime. So this is not given in the test, but this table is given to you in the test. And of course, unfortunately, the formula of this one is also given. This is a very important formula. You need to have it in your memory anyway. This is also given. Okay, so here you want to differentiate this. The method that you need to think about is that so you need to take something to be u so that that function be a function that you can differentiate based on the table that you have. Yes. So for example, if I ask you to differentiate this, it's very easy to see in this case. If I take this one to be u in my head, then it becomes u to the 5. But u to the 5 is among those functions that I know how to differentiate. Yes. So yeah, you can start immediately differentiating it. So how should I differentiate? Okay, tell me, what should I do? U to power 5. It becomes what? 5 u to power 4, but don't write u and change it. Don't get used to this way of writing. It is too much. So u is this one. So it becomes x squared plus 5x plus 2 to power 4. But this is not finished. You need to remember to multiply by the factor u prime. But u was this one in your head. So this means that this becomes x squared plus 5x plus 2. And I really recommend you do not do it in one step, especially in the beginning. But then you realize that this problem is not finished yet because there is still a prime left. You have to continue this process until there is no prime left, and that is the final answer for your derivative. Yes? So it means that you have to copy and paste more or less a lot. Everything's up to here should be copied and pasted because there is no prime here. But I have to take the derivative of this one, which is a very simple matrix problem. It becomes 2x plus 5. And that's the end of the problem. Is that clear? Okay.
Well, shouldn't you
Pardon?
power of 4, 5?
Ah, yeah, thank you very much. Thank you. 4. So this is the final answer, f prime of x. Thank you. Okay, now let me write another one here. So probably I can put some function here. F of x equals to, what do you think about this problem? Number 5 over x to the 2 minus 3 to the 4. So be careful, let me mention it again. This is not a problem that you could solve in matrix C. If you wanted to solve it in matrix C, there was only one way for you to do it, to write this multiplied 5 times and then try to differentiate. So you see, you appreciate this method. Okay, this is also this is not a matrix C problem either. So you should be able to do it using these rules that we have learned here. Any ideas what to do? Louder, please. Yes, yes. So you are taking x to the 2 minus 3 to be u. That's correct. But before doing that, I myself prefer to bring it up and then take that to be u. But that is okay. That doesn't matter. So if I want to do it myself, I prefer to first bring it up. 5 is already there, so it becomes x to the 2 minus 3 to the power of minus 4. And then you are right. I will take this one to be u in my head. It doesn't matter. You could take it u in the beginning, and then you have to bring it up at the end. It doesn't matter. Okay, so now, can I differentiate this function? Yes, because 5 is just a multiplicative constant, but then I have u to the negative 4, and I know how to deal with that one. So let us just do it immediately. So f prime of x is minus 4 goes down, multiplied by 5 is minus 20. And then u to power 1 less. So what is 1 less here? Minus 5. But it is finished? No, because I have to multiply by u prime. So let me write it explicitly. Even though this is simple, you can calculate it in your head. Okay, but is the problem finished? No, because there is a prime left, so I have to continue. So the answer becomes minus 2, x to the 2 minus 3 to the power of minus 5. The derivative of this is a very simple problem, so it's 2x. I myself prefer to simplify it, but differentiation is finished at this stage. Yes. So what is the answer? Final answer. So I would say that I will multiply minus 20 by this 2x. It becomes minus 40x. And then I will bring this back again to make it positive, to make the exponent positive. Yes, it doesn't matter, of course. Differentiation is finished there. So that is the derivative of this function. Yes? I hope that people can see. Okay, should I go so far? Okay, is that understandable? So now let me write some problems. So I will start writing them, but you don't wait for me, okay? You just start doing them so that when I come back and solve that, you have already worked on it. So hopefully you remember the formula. So let me erase this for having a better space. So I will write all of them here. So number 3, I have f of x equals to e to the power of the square root of x squared plus e to power x. So you will start doing it. You don't need to wait for me. This middle one is exactly in the book. Yeah, I give you 5 minutes, I think. It's a very important topic. You need to practice a little bit. This is a little bit technical in the beginning, but you will soon learn how to do it quickly. Okay, so let us start doing them. If you want, I can give you more time. At least you should have finished these two. I think they are not that far. Okay, so try to communicate with me so that if you are doing something wrong, I can correct you. So for this function, which is a good choice for you in the beginning? Yes?
Square x squared plus
The whole expression here, you are saying, yes?
square root.
Yeah. So this one is the best choice for you in the beginning. Yes? Let me just tell you, there's another misleading expression for taking to be u. Might be you think that this is good to take this one to be u, but this is not a good choice at this stage, because if I take what is under the square root to be u, then the function would be e to power square root of u. Yes? If I take this one to be u, then the function becomes e to power square root of u, and e to power square root of u is not in my table. Yes? So this means that this is not a good choice at this stage. So it means that, let me think a little bit differently. So then I realized that, okay, this is the best choice, because if I take the whole expression to be u and do not look inside, then I will have this function, e to the u, but e to the u is a function that I know how to differentiate. Yes, if I take c to be 1, that is exactly the formula for e to the u. Yes? So this is the first thing that you need to do. So you need to take this to be u, but in your head. Okay, so number one, the solution to problem number one, I will start differentiating this, but I am taking this to be u in my head. What is the derivative of e to the u? It becomes e to the u itself, but multiplied by u prime now. But u is this expression, so this becomes e to the x squared plus e to the x multiplied by u prime. Okay, tell me, is that understandable for everyone? Yes? Okay. Now the process is not finalized yet, because still I have a prime left. But now this is still not in my table, so I have to use the chain rule probably here. So what is the good choice here? The good choice is now to take this one to be u. This was not working in the beginning, but this is a very good choice right now. Why is that the case? Because if I take this one in my head to be u, I will have this function, square root of u. And the square root of u, hopefully, it's a famous function for you now. What's the derivative?
1 over 2 square
root of u, but because this u is a function of x, you also need to remember to multiply by u prime. Is that clear? So what I do, I continue, I would write e to power square root of x squared plus e to the x. If I take the derivative of that one, the derivative is 1 over 2 square root of u multiplied by an extra u prime because u is a function of x, not just x. So then I multiply it by 1 over 2 square root of u, which is this one again, x squared plus e to the x. But then I need to remember to multiply by the derivative of this u. And then you see that it's not finished yet because there is a prime left. I have to continue. But do I need any chain rule for this one? No, because this is the sum rule, yes? The derivative of the first one plus the derivative of the second one. So I will write it in this form. So this becomes equal to e to power square root of x squared plus e to the x multiplied by 1 over 2. So you have to copy and paste everything that is not affected. And then the derivative of this one is 2x. The derivative of e to power x is just the famous function whose derivative is equal to itself. And let me not spend time on simplification unless it is necessary. So if you want, you can multiply these two in the numerator and write it more compactly, but that's the answer. How many of you were able to get exactly this answer? Okay, so it means that there is some misunderstanding going on. You need to ask me if you don't understand something. Is there something that you don't understand when I explain? Yes?
I have a question.
Yes?
Can you write it as
Can you speak louder?
Can you write it as 3 functions?
This is 3 functions. So the first function is this function. The second function is a square root function, and then the other one is exponential function. But that one, if you want to understand what is going on, that way of thinking is good. But after learning that, it's better to learn how to do it fast. So this method that I am teaching you is exactly the same method. Just do you remember? I got the formula from the chain rule. So I am respecting the rule that I learned from chain rule, but I am doing it in a way which is more efficient to do. It is not that tedious. Because if I make this function, for example, a composition of 4 functions, every time you want to think, okay, this function is composition of a lot of functions, and you want to follow exactly the formula, it would be a little bit tedious. That's exactly the same rule, but I want to teach you in a way that is more efficient to do. Okay, but do you understand now? Okay, so hopefully you can get the answers right. So here, number 4, what is your suggestion now? What is number 4? What is the first thing that I need to do? Cube root to what?
To 1 over.
Yeah, so exactly. And that's also my impression. So I would change the form of the function from the third root, because for the second root we have a different formula. We don't have to do that, but we cannot memorize all of them. So we have to do this one in this way. So yeah, I agree with you. I would write this one first in this form to the power of 1 over 3 first. Then I have to use the chain rule. There is no other way at all for this function. Yes? Because there is no formula that I can expand this in a finite. I can expand it in infinite series, but that's a different topic. But here, if I want to expand it, because this is a fraction, I cannot expand it. So there is only one way to do this. And then I think it's easy to understand that this is a good choice for you in the beginning. Yes? Okay, so why this is a good choice? Because if you do not look inside, you will see that you have u to the third. But this is something that you know how to deal with. So you bring 1 over 3 down, you subtract 1 from it, and then you need to remember that you have to multiply by u prime. Okay, so what I do, I start differentiation immediately. So 1 over 3 goes down, u to power 1 less. So let me write everything in detail here. 1 less means 1/3 minus 1, if you can do it in your head better. But you remember, it's not finished. I have to multiply by u prime itself. And if you don't mind, let me get rid of this table here. Okay, but it is not it's not finished yet. I have to continue. So it's 1/3. And then I have e to the 2x plus e to the negative 2x plus 1. And then I have 1/3 minus 1, which is minus 2/3. And then the derivative of this doesn't need any chain rule. The derivative of the first one is actually the sum rule. The derivative of the first one is 2 times e to the 2x The second one is minus 2e to the power of minus 2x. The derivative of 1 is simply 0. For this one and this one, I use this formula here in the table. If you want to, you can bring it back and write it. Let me just do it for this case. So I would write, for example, I can factor a 2 out. It becomes e to power 2x minus e to power minus 2x. Then I have a 3 in the denominator. I will take this one to the denominator. It becomes positive 2. And then I can write it in this form of a third, yes, a third root. Yes? So I am using this formula. So these are the things that you really need to know very good for derivatives. Yes? So I bring this down. It becomes positive 2/3. And then this denominator goes here. And this will go for the power. Exactly according to this form. Questions? No? Okay, so now we go here. Number 7.
We did it to number 5.
Ah, okay, sorry. I jumped ahead. Yes. So number 5. Okay, the number 5 is very compact, but if you really can understand and do it, it means that you are on the safe side. You could understand everything regarding the chain rule. Okay? So I want to differentiate this function number 5. Yes. So number 5, I need to have a choice for u. First of all, do you understand what's going on? This is a string of exponents. So how many functions are involved? Can you tell me? So if you want to calculate this, how do you calculate this for a given x? For example, say that I give you x is equal to 1. How do you calculate this? Yes? So it becomes 1. 1 to the 2 becomes 1. And then e to the power of 1 becomes e. And then e to the power of e becomes e to power e. So this is the string of calculus. This is different. You see, let me just mention again. A to power m to power n is different from a to power m in brackets to power n. These are different, yes? Here, you can simply multiply the exponents. It becomes mn. But here, you are not allowed to multiply them. So if I have 2 to power 3, this is 2 to power 8. But if I have 2 to power 2 to power 3 with brackets, it is 2 to power 6, and they are different. Okay? So this is without pair of brackets, actually. Okay, now if I want to calculate the derivative of this one, which one is suitable to take for you in the beginning? Yes?
E to the power of x to the power of 2.
Yes. Yeah, that one is the best choice at this stage. Why? Because then I will have e to power u. E to power u is one of those famous functions that I know how to deal with. Okay, so tell me, what should I do? I would write f prime of x. I have e to power u, but I know how to take the derivative of e to power u, which is e to power u itself, but I don't need to write u. I know that this is u. But this is not finished because I have to multiply by e to power, by u prime. Yes? Okay. Do I need the chain rule here? Yes or no?
Yes.
Yes, because this is not x. It is x squared. It's a little bit different, but it is different. So it means that which one is suitable to take u here? This one. You need to take this one u. Why? Because of the same reason. E to power u, I know how to deal with. Okay? So I will copy and paste this first part. And then I multiply it by e to power u. This is this one. Yes? But it is not finished. I have to multiply by the derivative of x to the 2. But the derivative of x to the 2 is very simple. It's just 2x. So what happens? It becomes 2x. Let me write 2x on the right. And then I have e to power e to power x squared multiplied by e to power x squared. So that is the derivative. So if you want, let me write something. Do you agree with me that I can write it in that form? Yes? Because now I am multiplying two exponents. The bases are the same. So I write the bases and I add the exponents. It becomes that one. But for the time being, it's okay if you stop here. But that's also easy to understand. That's also correct. So this problem is very simple. But if you really understand what is going on, it means that you understand the chain rule. Okay? And then you need to practice more and more. So this problem is from the book. Okay? I just want to wait for 2 minutes for you to do this yourself. Okay? So just do this one, number 6 yourself. I will come back to you again. People can see it there. Yes. Number 6. Okay, finished? Even if this is not finished, at least you should be on the right track because I want to go forward a little bit. So what is the first step you did? No one else? I don't want you to give me the final answer, but what is the starting point? What do you think it should be the starting? Yes?
I move x and x square root of x up.
And then what happens?
Then it becomes x to the minus 1 and plus x to the minus 1.
No.
No.
The first one is correct, but be careful. This is not the correct thing you did. So let me mention, if I have this situation, then it can be written as this. But if I have this situation, I cannot move them separately. Okay, so you cannot write a minus 2. Is that what you meant, if I understood correctly? Something like around this. Okay, be careful. This is not correct. But if you want to do it, there is only one way to do that. And then this is because when you have addition, they are bounded together. They cannot separately move around. Okay, so this means that you can write it in this way if you want to. Because the power of this one is 1, and then when you, this is the only way that you can do it. No way, no other ways. Okay, is that understandable?
Yes.
So make sure that you really understand. Remember, this is a rule of thumb. If you have addition, subtraction, they are bound together. They cannot move around freely. Either you should take all of them together. Yes, they're like a family. Okay. Okay. So here, what we want to do. Yes, the first idea was correct, but that was a miscalculation. So I think now the idea is clear. I can take this one to the numerator, make the power negative. But let me just try to understand these things. Don't make things hard for yourself. So if I have a fraction a over b, and then I have an exponent there, you don't need to explain it all the time because this is the 3rd grade, yes? So you can just write b over a and then write it minus n. This is always possible, yes? Because why that's the case? Because here I can write it as b over a to the power of negative 1. This is the reciprocal of b over a, which becomes a over b. And then I have another power of n, so I multiply them, it becomes this. So here I would say that I will interchange these two. And the price that I have to pay is to make this exponent negative. But there is no point of writing 1 in the denominator, so I take it away. Okay, so what I want to do for number 6, I would write f of x is equal to x plus square root of x to the negative 4. Is that understandable for everyone? And I told you that this is a level 2 problem in the book, so it's not that hard. Okay, so how should I do that? Is there any choice for u? Yes, this should be taken to be u. Why this is good? Because then I will have u to the negative 4. I know how to take the derivative of. So the f prime of x is equal to minus 4 goes down, and then u, which is this one. But instead of negative 4, what is the power now?
Negative 5.
Negative 5. But is it finished?
No.
No, because I have to multiply by an extra u prime here. And then I have to continue. Yes? So the copy-paste part is the first part. And then I take the derivative of the first one. This is what is the name of the rule here that I'm going to apply?
Addition rule.
Addition rule. The derivative of the first one, 1. The derivative of the second one, hopefully, is also famous for you. So what's that? 1 over 2 square root of x. So that the differentiation is finalized here. But if you want, you can make it a little bit simpler. But you don't need to, of course, here. Let us not spend so much time. So I would say minus 4 in the numerator. I will take this to the denominator. And then you will have 1 plus 1 over 2 square root of x. And the answer in the faucet is different a little bit from this one. I recommend you to try to get this right according to exactly. You need to do a little bit of common denominator simplification and those things. I really recommend you to go and do that yourself. Okay, let us speed up a little bit. So I want to take the derivative of this number 7. What is the first rule that I have to use? This is a function. I want to differentiate it. It doesn't necessarily mean that always you have to use the chain rule. Yes, you might have the combination of different rules for differentiating a function. So what is the first rule that I have to apply here? Addition rule. Because why? I have the sum of 3 functions, so I have to apply the addition rule first, the sum rule. And then for this one, I don't need anything extra. That's enough. This one I don't need. But for this one, I need the chain rule. Yeah, so that is what you understand. But let us do this quickly here. So number 7, f prime of x is equal. Let us do it in our head. The derivative of square root of x is just simply 1 over 2 square root of x. The derivative of this one is also very simple. It is 6x. And then you can do this in your head. This is supposed to be taken to be u. E to power u is e to power u. But it is not finished yet. I have to multiply by u prime. But u prime is also so simple that you can do it in your head. So it is 4x plus 5, yes? You just multiplied 4x plus 5. And that's the end of this problem. So here, let me finalize that problem here also. Number 8. Okay, can you help me to do that? What is the first rule that I have to apply here? This is the chain rule, yes? There is no other way to do it. So what is good to take it as u in the beginning? Yes, just say it. 2x to the 3 plus 5 square root of this. Why? Because if I take this one to be u, then I will have this familiar function square root of u. Okay, so take the derivative of this. It becomes 1 over, hopefully you remember, 2 square root of u. But don't write u and then replace it. Just quickly write this. But is it finished now? No, because I have to remember to multiply by u prime. I would recommend you, if the function is complicated, don't be in a hurry. You just write it down patiently. Okay, now I have to apply a rule here. The first rule that I apply is the sum rule. The second rule is the multiplicative constant rule. And this one doesn't need any chain rule, but this one needs a chain rule. Yes, that's a combination. So I need to continue like this. Okay, so this becomes equal, the copy paste part, you just quickly do it, 1 over 2 square root of 2x to the 3 plus 5 square root of x squared plus 1. And then the derivative of the first one is just simply 6x to the 2 plus 5. Okay, can you do that one in your head as well? So of course, you know that this needs a chain rule. What is the suitable choice of u? I think you have enough experience now. This is a good choice for you. And the answer of square root of, because I have a 5, I wrote the 5 here. What I am applying is the constant multiplied by a function rule. So I didn't do anything with 5. I'm concentrating on taking the derivative of this bit. So this becomes 1 over 2 square root of u, which is x squared plus 1. But you know that this is not finished. So I have to multiply by u prime. But this is so simple that I can do it in my head. The u prime is 2x. I multiply it by an extra 2x here. Of course, if you want, you can simplify this 2 with that 2 and write it a little bit more compactly, but we don't need it to do it here. I want to go to other problems. So this is a very important type of problems. It's very, very important. If you want to go to technical universities, anyway, if you want to study mathematics, this is with you all the time. Okay? And then there are other types of problems that is also in the book. I want to talk about them, that you need to know the chain rule to be able to solve those problems. So let me switch gears a little bit to give you other taste of other flavors of the questions that we can use. Chain rule to solve. So example, yeah, let me write it in this form. Let h of x be f of g of x, and let so these numbers should be adjusted very well, otherwise it is not possible to solve. So f prime of 0 is 1, g of 0 is 0, and g prime of 0 is 3. So you don't know anything about functions f and g. You just know something locally about f and g. You know what is the value of g at 0, what is its derivative at 0. You don't know anything about the function g except these 2 pieces of information. And for function f, you only know this. Okay? And then determine h prime of 0. So this is a very simple question, but these type of questions you also see in the book. And that's another application of the chain rule. Okay, so you see that I'm supposed to calculate the derivative of a function at some point. There is only one way to do that. You should differentiate your function first, and then when it is done, replace x with 0. Okay? But then when I want to start differentiating, I realize that this is written as the composition of two functions. So it means that I have to apply the chain rule. Yes? So it means that if I want to solve this problem, first of all, I have to take the derivative of my function. But because that's a composition of two functions, I need to read this from the question, from the formula sheet, or remember. I really advise you to try to remember this very important formula. And then you multiply it by g prime. So this is nothing except rewriting the chain rule once more in front of my eyes. And then I am going to calculate h prime of 0. So what does it mean? It means that after differentiating, which I have done it here, I need to replace x with 0. But when I replace x with 0 on the left, I have to replace x with 0 on the right as well. I get this. And then whatever you need is given in the problem itself. So let us see. To answer this question mark, this is my question mark, I need to know this part, and I need to know this part. If I know them, I multiply them, I get my question mark. But let us see. G prime of 0 is given directly in the problem, so I don't have any problem for the second bit. But what happened for the first one? Two pieces of information is provided for that, yes? Because first, let me just write it in two steps. What you do, instead of this g of 0, you read it from the problem. What is that? It is 0. So then I go to the next step. It becomes f prime of 0 multiplied by g prime of 0. Then I go to the next step. What is f prime of 0? It's given to be 1 in the problem. Okay? And then multiplied, what is g prime of 0? It's given to be 3. So if I multiply them, it becomes 3. Is that understandable? And then you realize that I have to think wisely. Otherwise, for example, if I give you f prime of 1 is equal to 1, you cannot solve this problem because I am giving you that g of 0 is 0, and then you need f prime of 0. Yes? If I give you f prime of 1, it is useless for this problem. Yes? So this should be fine-tuned so that you can solve it. And there are some examples in the book of this kind. Is that clear? Okay. Now let me make it a little bit harder. This type of problem is a little bit harder. Okay. So let me erase this. Hopefully this also works because I did them in a hurry. So example. Let's say, for example, k of x is equal to the composition of three functions, f of g of h of x, such that h of x is given to you directly. H of x is given to be 5x squared plus 3, such that h of x is this, g of 8 is 2, g prime of 8 is minus 1, and f prime of 3 is minus 3. Determine k prime at 1. I want to wait for you a little bit, okay? So let me erase this. This is distracting. I think you have this in your memory, hopefully. I don't need it. So let me write it here. Yeah, I just give you 2 minutes. I think it's enough. Yes?
I remember you talking about a varying size parentheses. How do you do those?
If you want to do it automatically, you can write left. For example, if you want to use parentheses, and then you have to end it with right. It's not that beautiful, but it takes, so I prefer, because I know, for example, I was studying a little bit about art of LaTeXing. So for fractions, if you use this will give you brackets that big. But this is useless, yes? Because for human eyes, probably this is much more beautiful. And I don't know, I also prefer this one. But if you want to have like this, it is done automatically. If you want to do this, I have realized that this big brackets will work for fractions.
Yes.
Yeah.
No, I use big for fractions, but now when we have 3 decimal ones, I would need 3 sizes of brackets.
3 sizes of the brackets. We have big, so we have big, and then we have this capital big, and then I don't remember, we have B, big, another G. Which one is bigger? You can just Google it around. I don't remember. But this will take care automatically, but I don't think it will take care about this. Because I think usually in the books you see that they have written with the same size of brackets. The reason that I am writing it in that way, it's good from pedagogical point of view. You can have a good feeling that something is inside. But I think if you see math books, they write all of them with the same size of brackets, which is a little bit not pedagogical. I don't know, you can test it. I think if you use left and right for these brackets, it will keep it the same. I don't know. You can just check it yourself. Yeah, that's also something that you can, that is more or less subjective. Okay, so could you solve this problem? Not yet? Okay, so what you need is first, do you remember I talked about the 3 functions version? We talked about 4 functions version. So first of all, you need to know, how should I write this formula, which was only for 2 functions, for more than 2 functions? We talked about that. If you go back to the video, you will see that. So how should I do that? I gave you a rule of thumb. You see, first of all, this is easy to remember. You have the derivative of the outer function multiplied by the derivative of the inner function. This is also the same. If you have forgotten, you don't need to work hard for your memory. You can just use this rule of thumb. How many functions are involved here? 3 functions. So I will take the derivative of the first one. I will take the derivative of the second one. I will take the derivative of the third. Yes? I'm just giving you the rule of thumb. For the last one, what is inside it is just x. You just put x. For the second one, what is inside it? It is h of x. So you have to put h of x. Yes? Hopefully. If not,
I think they are.
they are not.
I think g of h should be equal to 3.
Yeah, then it would be fine.
So might be, let me see. I don't know, I have written 2. Let me come back. It might happen because I did it in a hurry. Okay, so it should be fine too. Okay, so let me just repeat you. If you have more functions involved coming after one another, So if that is the rule of thumb is simple. How many functions are involved? 3 functions. So if you want to write the chain rule for the three functions, you take the derivative of the first one, take the derivative of the second one, take the derivative of the third one. Okay? And then what is inside h is x, so you just put x. What is inside g is h of x, you put h of x. What is inside f is gh of x, so you put gh of x. If you remember this rule of thumb, it is not hard to generate something like this. Yes? So you write the derivative of all functions, one after the other, multiply together, and then you see that instead of inside h, I have only x. Instead of g, inside g, I have h of x. Inside of f, I have g of h of x. So at least you know how to write the formula quickly without referring to your memory that much. Okay, but now I want to calculate h k prime of 1. So k prime of 1, I have to replace x with 1. Agree? So this becomes f prime of g of h of 1. Yes? And then this becomes g prime of h of 1 and multiplied by h prime of 1. This is at least completely correct. Now let me come to your question. Let us see that if I have made something wrong. H prime of 1 is easy to calculate, yes, because h of x is given to me. So if I want to calculate h prime of 1, I have to do what? I have to calculate the derivative of h first, so which becomes 10x. Okay, so what is h prime of 1? Is just 10. Agree? And then I go here. For calculating this one, I need to calculate h of 1 first. But h of 1 is also simple. What I need to replace x with 1. So let me tell you, what is h of 1 then? It's 5 plus 3 is 8. So this means that this is 8. If that is 8, this one is also 8. Yes? Now, do I have information about g prime of 8? Yes, so far so good. Do I have g of 8? It is 2, but you are right. This should be, you are talking about this tree, yes? This tree should be 2, you are right. Thank you. So let me, I was thinking you are talking about this. Okay, so I made a mistake. No, I wrote f prime of 3, so that's not working. You are right. Thank you. Okay, but hopefully you understand what's going on. So h of 1 is 8, h of 1 is 8, but now this is g of 8. G of 8. G of 8 is 2. And now everything is ready. So f prime of 2 is minus 3. I corrected it, sorry. And g prime of 8 is minus 1. And h prime of 1 is 10. So the answer would be 30, yes? Is that correct? Okay. So you see, this is also one type of problems that you need to know. But of course, this was not in the book, but the previous one was somehow in the book. Okay? Is there any question here? Okay. Now, I want to talk a little bit from different points of view about the chain rule. So let me write it in this way. The chain rule is this. I have h of x is equal to f of g of x. Then I can imply that, I can conclude that h prime of x is equal to f prime of g of x, g prime of x. Okay. But let me tell you something. Let me change the letter h. So let me replace h of x with its with the expression which is equal to it. Yes. What does it mean? It's very important to write it in this form. And if you look at the chain rule in this way, it's really, really important to understand that. So instead of this h of x, I put f of g of x. Then this becomes prime because I have a prime on top of that. Then it becomes equal to f prime of g of x times g prime of x. Okay, So there is a very interesting point going on. So you see, I have two symbols, two expressions very similar together. Yes, one of them is here, and the other one is here. In the beginning, if you see the chain rule only in this way, I don't know, always books write like that. So this is what is a little bit misleading. I haven't seen even one book has written it like that. This is very strange. So you see, you might think that they are the same things, but at least when you write it in this way, you appreciate the difference. Yes, f of g of x totally prime is not the same thing if you put prime here. Okay, what is the difference between these two symbols mathematically? This means that first you need to replace x with gx. You get something, a new function. Then you take the derivative. This the other way around. You first take the derivative and then replace x with g of x. And then this shows that they are not the same. They differ by this factor. Only in some special cases these notations are the same. For those special cases which by coincidence the derivative of g is 1. Yes? If the derivative of g is 1, then these two are equal. But if the derivative of g is not 1, which is most of the cases, then they are not equal. So let me just write it. I don't know why. Because this, I don't know, if you go to calculus of several variables later, there is a very harder version of the chain rule for functions with more than one variable. Okay? And if you don't understand the chain rule in a good way, you will also start suffering there, especially the professors doesn't care usually about teaching properly. And so this means that you really need to, because professors usually care about research. And that's also a very bad thing in Sweden because there are only one type of positions at university, that's only research positions. But in other places, at least even in Europe, there are two positions, teaching positions and research positions. It doesn't mean that the professor employed for teaching doesn't research or the other way around. But the percentage percentages are different. Okay. Okay. So here I want to write this down. You need it in the future at least. So what is the meaning? I want to describe this symbol for you. So when you see prime is out there, it means that first replace every x of f of x with g of x, and then differentiate. Yes? Is that clear? So we first replace and then differentiate. Now let us repeat this together. What is the meaning of this symbol then? You see, they are very, very similar, but they are totally different. What is the meaning of this? If you see this symbol, what is the priority? Here the priority is with replacement, then differentiation. Here the priority is with differentiation and then replacement. So first, differentiate f of x to get f prime of x, and then replace x's in f prime of x with, replace with is correct or by is correct in English? Replace with? Yes, okay. In f prime of x, replace x's, the plural form of x, in f prime of x with g of x.
You would use by if it's like replaced by.
Ah, okay, yeah, that's weird. Yeah. Is that understandable? And then the chain rule tells you that don't think they are the same. They are not the same unless this factor is 1. So now For example, let me ask you something. Do you think that this symbol and this symbol are equivalent? In principle, the operation that gives rise to this is different from the operation that gives rise to this. But because of the chain rule, these are the same. Why? Because what is playing the role of g of x here? X plus 1. And the derivative of g of x is coincidentally 1, so there is no difference between these two. Is that understandable? The most famous one is this one. So for one single function, it doesn't matter if you put prime here or if you write f of x and put prime here. They are equal, 100%. Because the derivative of x is 1, and this x is playing the role of g of x, so these are equal. So these two are the same if and only if the derivative of the inner function is equal to 1. If it is not, this is not possible to, they are not the same. Be careful about this point. And then this is also something very useful if you think it in this way. Let me give you an example. Can I erase this now? Okay. So let us see which type of examples we can solve using this idea. So let me make it very simple first. Example. This is also, by the way, at the level of the book. I would write, let f prime of x be equal to, very simple function, to x squared minus 1. What is the derivative of f of x squared? As simple as that. You see, someone has given me the derivative of a function, and then I want to ask about the derivative of this one, the derivative of this combination. Of course, you might say that I can find f, because you have studied a little bit of primitive functions. So you might say that, okay, I can guess my function, but assuming that this function is a little bit complicated and finding the primitive function is hard or sometimes impossible, but still you can answer this question. So this is what I'm saying, that, of course, it is not hard to guess what is the function whose derivative is this. It is x to 2 times x to the 3 divided by 3 minus x plus any constant. Yes? That's the general form of that function. But forget about primitive functions. You want to solve this using the idea that I told you. So by reading this question, what you understand? What is the derivative of this function? First of all, do you understand the question? The question is telling you that I have a function whose derivative is this. I don't have any idea of the original function. Forget about that. But I know that that's a function. In that function that I don't know, I go and replace x with x squared. I get a new function. And then I want to take the derivative of that function. Is that understandable? That's the idea of the question. Okay. One way to do this is find f and do the replacement and take the derivative. But I don't want to go through it because it might happen that this function is so complicated that I cannot find the primitive function, but still I can solve the problem. Okay, so can you tell me what is the question? What is the derivative of this? So what is wanted? The derivative of this function is wanted. Do you think the question mark is this one or the question mark is this one? Because it's very important. By reading this English sentence, what is the derivative of this? Do you think the question is asking for this or asking for that? The second. Because what is the meaning of f of x squared? It means that in the function f, x has been replaced by x squared, and then I am interested in taking the derivative. So which one has been done first? Replacement has been done first, and I want to take the derivative. So it means that this is not the case, because in this case, differentiation has the priority. So what they are asking is not this, but this one. Okay? So now everything is clear. So if I want to write it, it becomes f of x squared prime. Now, can you help me to write this? You need to remember the chain rule in this form. That's the chain rule. That's the same rule. But you need to understand what's going on. Okay, can you help me now? So what should I write? Yes? According to that idea, which one is playing the role of g of x in this problem? Yes? Just say it.
X squared.
X squared. So x squared is playing the role of g of x. So if I want to calculate this, according to this idea, I have to calculate f prime of x squared, but that is not enough. I have to multiply it by the derivative of x squared. Yes? But now tell me, is this easy? Yes. This is just 2x. This is, let me write it again, f prime of x squared. But now what do you think? How can I calculate this? This is f prime of x squared. Unfortunately, f prime of x is given. You need to remember what was the meaning of this. The meaning of this, do you remember? It was first differentiate, which we have already done in the problem, and then replace x with x squared. Is that understandable? So you need to have a good understanding of how to read these symbols. Yes? So here I would say that f prime of x squared means first differentiate, which is done, and then replace x with x squared. So this becomes 2. Instead of x, I put x squared. But after x, I have a 2. And then I have a -1. This expression should be multiplied by 2x. And then if you want, you can multiply that. So x to the 4, multiply it here, it becomes 4x to the 5 minus 2x. And that's the answer. So this is a very simple example to illuminate this idea that you really need to differentiate between this. So the time that you spend on derivatives and integrals, especially if you want to go to a technical university, it's really worth it. Otherwise, you need to, I know, because I'm also teaching those groups, and many students that I have are actually failing this calculus course for several times. So this can happen and it's too stressful. So it's better to start learning these things from here, okay? Okay, so this is something that I wanted to know. I wanted to share it with you. Then if you want, I can give you one example. I can see your faces. You're tired. I don't know how, because I'm speaking and running over with, but I'm not tired. I'm excited to speak more than 2 hours, more 2 hours for you. But yeah, you're bringing my mood down. When I see you, yeah, yawning. I don't know how you are not excited, but okay. Yes.
I was actually quite awestruck when you used the chain rule, and so when you ask the questions and they give an answer,
yeah,
I couldn't utter any words because I was just like, oh wow, that's
yeah, okay.
cool.
But I mean, I don't know. I think you are tired a little bit today for some reason. I don't know. But I really want to say something. I don't know, how do you think about this pandemic situation or something? It's bringing the mood of everyone down, probably except me. So I don't care about what's happening outside. But what I'm trying to say is that this is temporary. If you let this situation beat you, then unfortunately the life is not that fair that you might think. You need to pay the price in the future, and nobody cares that you are from that generation confronting actually pandemics. So this is what. So you need to find a way that you beat, because after 1 or 2 years, if we cannot go over it, probably the humanity will be wiped out. So we don't need to be worried. And if we are living, that means that we have survived. So then you need to find a job, you need to continue your education and everything. So that's what I'm saying. Don't let this happen. Just try to, I don't know, doing exercise is also very, very helpful these days, but unfortunately gyms are also closed, but you can do some exercises at home. Yes?
It's not like the gyms have exceptions.
Exceptions?
I mean, SATs will be open because when they said max 8 feet, they made an exception for gyms.
Okay.
The state
Okay.
will be closing down their own gyms, but private gyms are still.
Okay. So if that's the case, I can still join my gym because my membership was expired. I was thinking that if I start a new membership, might be I'm losing the money because these days companies are not very good to give the money back. Yes. So yeah. So let us start. You need to find a way so that you can keep yourself fresh. Yes.
When something goes for like 2 weeks, they actually compensated everyone.
Yes, because my daughter is also joining for only 2 weeks. But what happens if this is going to?
Yeah.
But now they are not going to close it anymore.
Or say I read online from Nordic Wellness website.
Okay. Okay, so now let me give you one more question because we are supposed to end at 11:40. Yes. By the way, my lessons, the exercises and teaching are together. So when I ask you to do some exercises, don't think that, okay, I will do it later. Then you will miss. Okay? And then, by the way, if you want to go to university, you need to get used to this. Most of the work you need to take home. If you want a job that when you finish you are free, please don't try to go to university or academia. This is not the case. You have a lot of freedom in academia, so people like it. So you don't need to wake up in the morning and go to office, but you can go to the office in the midnight. Okay, but you have to go or somewhere. You need to do something. Okay, so what I'm trying to say, if you really don't like it, you don't need to force yourself to do that because then you will lose the best period of your life for something that you don't like to do at all. Okay, and I really don't recommend you to do that. So yeah, remember, even if you become a professor at the university, which is probably the highest rank, still most of the time you have to work at home. Okay, so I want to correct your mentality. If you don't like this way of living, the university is not probably that good for you. And on the other hand, I want to encourage you. This is the best possible career that you can have. Because it doesn't matter, assume that you don't want to do that, you go to, for example, work somewhere else, you need to spend 8 hours a day there and do the very boring job. But at least if you really like your subject, you don't feel it as if I don't feel it right now. Okay? Yeah, try to correct these things in your head. Okay, so let me give you one example. I hope that you can solve it. If you listen to me, you are able to solve this problem. So, example. Let f and g be functions. Let f and g be functions such that f of 5x squared plus 1 plus g of 3x minus 2 is equal to 2x squared. And hopefully I have written it correctly, but you can correct me now. You're an expert. So f prime of 6 is 2. Determine g prime of 1. Yes. If you can solve this simple problem, it means that you really understood what I told you about the priority operation, replacement, then differentiation, or differentiation, then replacement. Okay, since we have don't much time, so let me ask you, how do you think about the problem? Just talk to me, because don't think that I knew everything in the beginning. I have done a lot of trial and error that is not clear for you now. But the only thing that you need to take lessons if you want to, because I think you remember, you learn very good, but the problem is that you forget, you don't take lessons. For example, I have a lot of sample problems in my head. Yes, this can happen. So if you want to be experienced, you need to have a good understanding, not the details, but the general ideas. So what is the first step? You read this question, you take your pen, what is the first thing that you write? Yes?
The equation.
Okay, so this, okay, let us write that. Now, because I want to see how do you think. So you write the equation again, that's good, because that's in the question. It usually helps. Okay, so you put the equation in front of you, and then you read the question, you see the derivative is involved. Yes?
Maybe take derivatives of both sides.
Exactly. So it's not hard. Why I should be motivated to do that? Because I have something. Is there any notion of, is there any derivative involved in this equation? No. But the pieces of information provided for me is only related to the derivative. So that is the natural step, at least to dare to do. Yes, it might happen that it doesn't work. Then we can come back and say, okay, it didn't work. Let me do another thing. So then I want to take the derivative. Okay, now you yourself, can you tell me? I forgot your name again.
Carl.
Carl. So I will always mix your names. So Carl, so do you know how to take the derivative? You said to take the derivative of both sides. So let me just do that. This one is the simpler one. I do it. The hard one, I want you to do it. Okay. So how do you write? Don't do it. Just write. What do you write here? You said take the derivative from both sides. What do you write here?
F prime of 5x squared plus.
So let me write and then ask how many of you agree with him.
No.
You am I understood you correctly? You mean this?
Yeah.
So how many of you agree with this?
That we add times.
Not just don't go too fast. Do you agree that if I write this, this is correct?
It's wrong here.
Because now you are thinking that I am using the sum rule. Okay? But the sum rule doesn't tell you put prime here. I talked about where to put the prime is important. Yes? So yes. So if I want to write it, don't be in a hurry, especially for the problems that you are learning. This is 100% guaranteed. If I have something, a function equal to another function, the derivative of this expression is definitely equal to the derivative of this expression. Okay? Now, on the right-hand side, do you have any problem? No. So far, so good. It's 4x. Okay? But then I need to remember a rule for derivatives. What rule apply here? Which rule applies here? The sum rule. But the sum rule, because you see, if it was f of x, there is no difference to put the prime here or to put the prime here. Yes? But here, this is not the same x. So you have to respect what I told you here and put the prime where? Here. I am using the sum rule, but the prime should be for the whole expression. Yes? And then plus g of 3x minus 2, the whole expression. Is that understandable? Now, this becomes a chain rule. Yes? So according to the chain rule, how should I write it? Now I can flip this prime on here, but there is a price that I have to pay. I have to multiply by the derivative of the inner function as well. So you see, I am now flipping this prime here, but this is not the finished part. You need to multiply by the derivative of this expression as well. Yes? And then continue. Can I flip the prime from here to here? Yes, but the price that I have to pay is what? Multiply it by the derivative of 3x minus 2. Okay? And on the right-hand side, I will have 4x. This is the correct form. Do you get it? Yeah. So it's very important to put the prime up there. So let me continue here because we are near finished. So the derivative of this is simple. What is the x? It becomes 10x. So let me write it on the left-hand side if you don't mind. 10x multiplied by f prime, 5x squared plus 1. And then the derivative of 3x minus 2 is just simply 3. Let me write 3 on the left-hand side again. So 3 times g prime of 3x minus 2 is equal to 4x. So this is the correct form of differentiating this equation on both sides. Okay. Now read the question again. What is your goal? Your goal is to find g prime of 1. So can you tell me what to do? My goal is clear. My question mark is g prime of 1. This is not g prime of 1. This is g prime of some function. But I am asking you to find g prime of 1. What I have to do? X1 will work. Yes, you are right. Because that is a coincidence. Because if I put x equal to 1 here, this becomes what? 1. And then, yes, I could make it a little bit harder. This is a coincidence. Okay. But if I put x equal to 1, this means 10 times 1. You might say, why do you make it equal to 1? Let us wait and see what happens. I am replacing x with 1, then multiplied by f prime. What would be the answer inside? 6. Agree? If I put 1 here, it becomes 5 plus 1, plus 3 times g prime. If I put 1 here, it becomes 1. When I put x equal to 1 on the left-hand side, I have to put x equal to 1 on the right-hand side as well. Yes? And then what happens? 10 times 1 is 10. And then f prime of 6 is given to you in the problem. So this problem has been fine-tuned for these numbers. Okay? And then plus 3. And the g prime is my question mark. And then on the right-hand side, I have 4. So this is 20. And then there is only one part missing. And this is super simple. I move 20 to the right-hand side. So what happens? It becomes 3g prime of 1 is equal to 4 minus 20, which becomes minus 16. And I'm looking for g prime. So what is g prime? Is minus 16 over 3. Is that understandable? Okay. I wanted to share this with you, but might be, I don't know, I will not emphasize that much on this, even though that's not hard. That is also the chain rule. There is only one small part left, and that is the proof of the chain rule, which is beyond the scope of the book. But what I want to go through what is written in the book, and at least you will get some idea why this chain rule is correct in the first place. So that's not a rigorous mathematical proof, but that is a sketch of a proof. Or for a very big group of functions, that is the precise proof actually. Any other questions? Yeah? Okay, so thank you. Yes, so I will end up this live stream. Bye-bye. Yeah.